laser diode and the LED at low drive current. We're supplying the LED with volts right now. And at a certain voltage, we're going to notice it do a thing. Whoa, check it out, it did a thing. We're at 1.5 volts right now, and this is 1.6 volts.
What we're doing here is we have a laser diode that we're looking at underneath the camera microscope. And when we supply a current to the laser diode, we can see it start to emit. So if I turn this current up, we'll see more emission coming from the laser diode.
For this part, we're using the optical spectrum analyzer to measure the output spectrum of the LED, and we have found a peak wavelength of 631.8 nanometers.
So what we have here is our laser diode is emitting into this optical spectrum analyzer. We have the current well above the emission threshold, so we can see multiple modes here. These vertical lines here are marking the distances in nanometers between the modes of the laser. And we can see now if I adjust the current, we'll see mode hopping take place where now this mode is now preferred based on the cavity size. And if we turn the current down, now this mode over here becomes preferential. The mode hopping happens because as we increase the current, the temperature inside the cavity changes, changing the cavity size. For this part, we're measuring intensity peaks as a function of angle, so we're rotating the LED about its axis here, and we're measuring the differences in intensity peaks that we see here.
On the left, we see the laser diode as a divergent source, and on the right, we see that it has an asymmetric beam profile.
For this part, we are using the laser diode to measure divergence in the direction parallel to the p-n junction and perpendicular to the p-n junction.
In this plot, we see that the LED emits more strongly in a given direction.
For this part, we're measuring the polarization ratio. We have the laser diode emitting through a linear polarizer into our detector, and we're measuring the peak-to-peak voltage. So right now we're at our maximum at about 300 millivolts. And if we rotate this polarizer about 90 degrees, we'll see it drop down. And the ratio this gives us is about 6.25.
The LED is unpolarized, so for this portion it's just 1.
So what we have here is a LED emitting into an integrating sphere. We have it blacked out so we get just the LED hopefully going in. And then we're controlling the current through the LED as a function of voltage here, and we're reading the power output.